Hi students and welcome to today's session. Today we will be dealing with euploidy, and before that we have gone through chromosome elaborations, structural elaborations we have completed, and numerical elaborations. We have had an introduction about numerical elaboration, ploidy changes, haploid, monoploid, polyploid, etc. We have discussed in our previous videos, and I hope you all have viewed that videos and now you are clear with that concept. And in the previous video I have also mentioned about the reason for this ploidy change, that is the video was on non-disjunction, and I hope you are clear with that also, and now you will be ready to move on. So this is an overall flow chart showing different types of chromosomal abnormalities. As you all know, we have completed half of these. Chromosomal abnormalities can be of two types: structural and numerical. Structural changes results due to any changes in the chromosome, while numerical changes is the change in the number of chromosome. And structural changes can be balanced or unbalanced. Balanced, we have inversion, translocation, Robertsonian translocation in balanced type, because there we are not having any loss. We are not losing any portion of the chromosome. But in non-balanced type, there is deletion, duplication, and isochrome and ring chromosome. You don't have these two in your syllabus, so I haven't posted any video about that. So in deletion and duplication, there is change in the segment. In deletion, we are losing a segment of a chromosome, while here an additional copy of the segment is found. So here it is not balanced. And the numerical aberration, it can be polyploidy and aneuploidy. And polyploidy we have dealt in our previous video. So today this polyploidy or this ploidy changes, as I have mentioned in previous video, ploidy changes can be of two kinds. It can be euploidy or aneuploidy. So two types are there, euploidy and aneuploidy. Euploidy is a numerical change wherein the entire chromosome set is changed, whereas in case of this aneuploidy, there will be only change in the number of chromosome, not the whole set. Only one or a few chromosome will be found in addition, or it may be deleted. So it is not affecting the ploidy, or the genomic level is not affected in case of aneuploidy. So that is the basic difference between euploidy and aneuploidy. What was that? In euploidy, the numerical change involves the change in the entire chromosome set, whereas in euploidy, it involves only individual chromosomal changes. And this euploidy, it is actually this condition is found in somatic cells. The somatic chromosome number is found like multiples. It is found in multiple numbers. It is the multiple of basic chromosome number. So the basic set or the basic chromosome number, we use the term for that is monoploid. So in case of euploidy, the chromosome set will be found as multiples of this monoploid number. And in euploidy, it may be of several types. Euploidy includes monoploidy, haploidy, and polyploidy. Three of these have been detailedly explained in our previous video. So I don't think we have to repeat that again in this video. And just briefing it, haploidy is the condition which is found in the chromosome number in the gametic cells, while diploid organisms have their somatic chromosome number as diploid number, and monoploid is the basic chromosome set. And Again, this haploidy, it may be, we can say that this haploidy are of two types, euploidy and aneuploidy. In case of euploidy, here the number of chromosome is exactly the same which is found in the gamete cells. So the chromosome number is exactly similar to that found in the gametic cells. But in case of aneuploid, one chromosome may be found as addition or one chromosome may be less when compared to the gametic chromosome number. So that is the difference between euploid and aneuploid. And this polyploidy, as you know, it is here the chromosome number in the somatic cells will be more than, it will be the multiple of, it will be found in multiples. So the somatic cells will be having a chromosome number which will be multiples of the basic genome. And it can be divided into two types, autopolyploidy and allopolyploidy. And again, we have also mentioned several other types in which comes under autopolyploidy, that is triploidy, tetraploidy, pentaploidy, and so on. And aneuploidy, coming to aneuploidy, the details we will be mentioning it with the help of some figures. See here, aneuploidy, it can be hypoploidy or hyperploidy. Hypo means lower, that is the chromosome number will be less, one or two chromosome will be less compared to the normal chromosome number. In hyper means higher, so here the chromosome number will be additional, one or two chromosome will be found in addition. This karyotype, this is a human karyotype, and here it explains monosomy. As you can see, monosomy is a type of aneuploidy, particularly hypoploidy. So monosomy, we can denote the condition as 2n-1. So the diploid number which is 2n-1. So one chromosome will be less than the normal diploid condition. So see here, this is a karyotype of a human cell, and here you can see, as you all know, we are having 23 pairs of chromosomes, of which 22 are autosomes. So you can see here, one chromosome, two chromosome. Chromosome number 1 we have 2, chromosome number 2 we have 2, and one of this chromosome is from maternal origin, one from paternal origin. So likewise, 2 copies of each chromosomes are present. That is why we call it as pairs. Chromosome 1 is a pair, chromosome 2 is a pair. Likewise, we have 22 pairs of autosomes and 2 sex chromosomes, X and Y. So as it is X and Y, it will be a karyotype of a human male, and if it was a female, then we will be having XX. So that is the condition. So here the chromosome Y is missing, right? We cannot see the chromosome Y here. So that is chromosome Y is missing. So this condition can be represented as 2n-1. 2n is the normal diploid condition from which we have a one chromosome less. So we can represent this this is called what is called monosomy, and we can represent it as 2n-1. See here, this is nullisomy. In nullisomy, this is a normal diploid condition where we can see 4 pairs of chromosome, and these 4 pairs of chromosome, when nullisomy occurs, in case of nullisomy, one pair is missing here. So in nullisomy, an entire pair is missing. So how we can represent this? This condition nullisomy can be represented as 2n minus 2. So that is nullisomy. And next is the condition trisomy. In trisomy, one chromosome will be found in addition. So this is also a karyotype of normal female human being. So here you can see 22 pairs of autosomes can be seen here, and here 18th chromosome. Normally we have 2 copies, that is it exists as pairs, 2 copies are found, but here there are 3 copies. So in this condition we are having an extra copy of chromosome number 18. So this condition is called trisomy, and we can represent this condition as 2n plus 1, because 1 is found in addition. So as you can count, there will be 47 chromosomes in trisomy condition. And this is the condition of tetrasomy. Here this is also a karyotype of human being, and it is a male cell, because you can see X and Y. So here also up to here chromosome number 7 it is normal, but here in the case of chromosome number 8 you can see 4 chromosomes at chromosome number 8. So that is, we are having 2 copies in extra. Chromosome number 8 is having 4 copies here, that is 2 are in extra. So this is the condition called tetrasomy. One chromosome, instead of having 2 copies we have 4 copies. So that is condition called tetrasomy, and we can represent this condition as 2n plus 2. So here we will be having a total chromosome number of 48. Normal condition it is 46, that is 23 pair of chromosome, that means 46 chromosomes, but here we are having 2 extra, so 46 plus 2, 48 will be the total chromosome number. So that is the condition of tetrasomy. And this is about autopolyploidy. Polyploidy can be of 2 types, autopolyploidy and allopolyploidy. In autopolyploidy, the multiple, I have mentioned about polyploidy, that is the multiple copies of the basic set of chromosome will be present, and here the multiple copies will be of the same species or the same cell. See, this is the karyotype of a parent species, and when meiotic division occurs, some error occurs, and as a result of meiotic division, this unreduced gametes are formed. That is, normally when meiotic division occurs, gamete formation occurs, and gametes will be having half the number of original chromosome number. But see here, meiotic error occurs and the gametic cells are having the same number of chromosome as the parent cell, and self-fertilization occurs. These 2 gametes fuse and form a zygote. So the zygote will be having this chromosome number plus this chromosome number. So this is the normal the zygote formed, which is having a autopolyploid condition. So I hope you are clear. See, I repeat, this is the parent cell which is having a diploid number 6, that is the chromosome number is 6. You can count here 2 plus 2 plus 2, 6. And this cell is supposed to undergo meiotic division to form the gametes, and the gametes in normal case will be having reduced chromosome number, that is the gamete cells will be having half the number of parental chromosomes. So we are supposed to get 2 gametic cells with chromosome number 3 and 3, right? But here you can see the chromosome number is 6 and 6. So that is because of a meiotic error, that is non-disjunction. And when these 2 abnormal or unreduced gametes will fuse to form a zygotic cell, a zygote will be formed with a chromosome number double that of the original parent. Parent is having diploid chromosome number 6, but when these 2 unreduced gametes fuse and form a zygote, that zygote will be having a chromosome number 12. As you can count, 2 plus 2 plus 2 plus 2 plus 2 plus 2. Total is 4n condition, that is 12 chromosome. This is a tetraploid cell, because this is having 4n condition. Normal n condition is 3 and diploid condition 2n is 6. So 12 is 4 times higher than the normal chromosome number, that is the basic set, which is 3. So basic set is 3, and here in this case the zygote is having 4 times higher chromosome number. So this is called tetraploid. That is, and here it is called autopolyploid because both the species, both the gametes are, or the chromosomes are from the same species. Here this explains about allopolyploidy. In allopolyploidy, the multiple number of chromosomes, or the chromosomes will be in multiple, and that chromosomes are not from the same species. Here this is species A and this is species 2. Species A is having a diploid number 4, and here it is having a 2n is equal to 6. So in species A is having some error during gamete formation, and their non-disjunction occurs and gametes is not reduced. Unreduced gametes is formed. Here 4 is the chromosome number in the gametes also. But in case of species B, you can see it is normal gamete. Half number of chromosome is present in the gamete. Here you can see 3, and actually it was 2n condition was 6. So this is a normal gamete. So this normal gamete fuses with the unreduced gamete and a hybrid is formed. Here what is the chromosome number? 4 from this and 3 from this. So 4 plus 3, 7 is the chromosome number in case of hybrid. And that this hybrid or this polyploid is formed from 2 species. And then what happens? This hybrid cell produces a gamete which is also unreduced. There also unreduced gamete is formed, and the chromosome number is 7. And again species B forms a normal gamete with chromosome number 3. And this 7 unreduced gamete with 7 chromosome number fuses with the normal gamete from species B with chromosome number 3, and they fuse to form a allopolyploid, viable fertile hybrid. And here you can see the chromosome number 2n condition is 10. Okay, so you can see red colored and blue colored. Red color is species A, blue color is from the species B. So this cell, this polyploid or this hybrid is having chromosomes of 2 different species, and also they are found in multiple sets. So this type of polyploidy is called allopolyploid because it involves 2 different species, and the chromosome number is also different from the parent cells. Species B is having 6, 2n is equal to 6, but here we are having 2n is equal to 10. Species A was having 2n is equal to 4, and here we are having 2n is equal to 10. So this is a case of polyploidy, and since 2 species are involved, it comes under allopolyploidy. So that is all about euploidy. Hope you all understood. If you are having any query, please feel free to contact me. Thank you.